right, so Pythagorean triples. First thing to always identify is where is C? Okay, A and B are interchangeable, but I think it's always really important to identify C. And C is opposite the right angle. So in these two, we're finding C. But notice in this one, we have C. And we need to find either B or A. I think it's really important because the most common mistake is always putting in the numbers for A and B, and that's not always the case. 1 and 2, it will be. But I still suggest you always start off by writing the original equation. Doesn't take long. And then filling in your numbers. So 9 squared plus 12 squared equals C squared. All right? 9 squared is 81. 12 squared is 144. And then that's going to be 225. Got ahead of myself there. We're going to square root both sides, and that is 15. C equals 15. All right. Again, real quickly, a squared plus b squared equals c squared. I plug in, doesn't matter the 7 and the 8, it does not matter which one's which, they're interchangeable. So 7 squared is 49, 8 squared is 64, and c squared is c squared. Now I add those together. That equals 113. You square root both sides. That is not a Pythagorean triple. All right? Because if you took the square root of that, you would get 10.6 approximately. So that is a no. It does not make a Pythagorean triple. All right, over here, a squared plus b squared equals c squared. Now remember, in this case, it doesn't matter what you plug this in for, all right? 4 squared plus b squared equals 8 squared. So this is 16 plus b squared equals 64. You're going to subtract 16 from both sides. So that's b squared equals 64 minus 16, which is 48. Square root both sides. You do not get a perfect square. So this one is also no. That would be a decimal. If you think about it, 49 is a perfect square, which would be 7. So this would end up being 6 point, like 9. So that's a no. All right, verify the lengths form a triangle. Is it acute, right, or obtuse? So just as before, it's always important to identify C. The hypotenuse always has to be the longest side. So that's going to be 40, 13, and this one's a tricky one because which one is it? So you actually have to do 10 times the square root of 3 and figure out that that's approximately 17.3. Approximately. So that means this is C. And we put it last, but you always should verify. You don't want to assume. So that's the longest side. So we're going to do the same math as before. We're going to do our a squared plus b squared equals c squared. And again, I like to do this every time. It doesn't take long. And it just helps keep you on track to think about where everything goes. All right. So I put the first two numbers in, 24 squared plus b squared. I'm going to leave this blank because we're not actually going to, we don't know what this is going to be. And then 40 squared. Okay. I don't know why I put a b there. That was silly of me. So let's put in 32. All right. So now I'm just going to do the math. All right. I do not know these off the top of my head, so I'm going to use a calculator, which you should also. So 24 squared is 576. 32 squared 1024. And then 40 squared, that's pretty easy. 4 times 4 is 16. Add a couple zeros. So now we just have to add 1024 and 576 and compare it to 1600. So 1024 plus 576 equals 1600. So 1600 equals 1600. Okay? That means since it matches, that's a right triangle. Because the Pythagorean theorem works. In other words, this right here is a Pythagorean triple. So let's do this one. 7 squared plus 9 squared equals 13 squared. I'm not going to put the equals because we don't know if it equals or not. So 7 squared is 49. 9 squared is 81. 13 squared is 169. I'm going to add these together. 9 plus 1 is 10. Carry the 1. 8, 9, 4 is 13. 130 and 169. So here, a squared plus b squared is less than 169. Okay? If a squared plus b squared is less than c squared, it's an obtuse triangle. So you might be able to figure out what this probably is, but who knows? We'll see. So 12 squared plus 15 squared equals, nope, again, we don't know equals, so don't put it, it's habit. 10 root 3 squared. Okay, so 12 squared is 144. 15 squared is 225. I'm just going to add those together right now. That's going to be 9. 4 plus 2 is 6. And that's 369. Over here, we're going to square this. Now, remember, this is really the same thing as 10 root 3 times 10 root 3. So we do outside times outside, which is going to be 100, times root 3 times root 3 is just 3. So that's 300. So this time, a squared plus b squared is bigger than c squared. Therefore, it is an acute triangle. Okay, so on to our special triangles. So here we have a 45, 45, 90. Now, it's a very simple relationship. If these angles are the same, the sides are the same. That simply means x is 6. Okay, it has to be. The legs match. The hypotenuse, going from here to here, well, you're getting the hypotenuse, which is bigger, which means you're multiplying. Okay, and the magic number for 45, 45, 90 is radical 2. So y is simply 6 radical 2, and we leave it like that. All right, 30, 60, 90. Here's my 60. Okay, now notice I'm in good shape here because I have the smaller number opposite the smallest angle, 30. So that's great. So always know where your hypotenuse is. It's a very simple relationship to go to the hypotenuse because all you do is double it. You double the short side. So x is simply 8 times 2, which is 16. Now, going to the larger side, I'm still getting bigger, so I'm multiplying, but the magic number on this one is root 3. So y is simply 8 times root 3. That's it. Now notice here I have my hypotenuse. So if I got to decide whether to go from the hypotenuse to the small side or the large side, the easiest thing to do is always go to the small side because all you do is divide by 2. Just like on number 8, we multiply by 2. We're getting smaller, so we divide by 2. So x is simply 10 root 2 divided by 2. That cancels, so I get 5 root 2. Now that I have the short side, which is what you always want to have, you're going to the larger side. What do we do over here? We multiplied by radical 3. So y is going to be 5 root 2 times radical 3. And all we do here is inside times inside, so it's 5 radical 6. And that's it. Right, it says draw a picture of your work on the previous page. That should have been here. Sorry for the mix-up. Number 10, find the length of the side of a square. So first off, I'm just going to draw a square. Okay? It says find the side length of a square with a diagonal of 32. Okay? Well, this is a right triangle. It's a 45, 45, 90 right triangle, and these match. So basically what we have here, I'm just going to make this a little bit easier, is this, and this, and this, and this. So remember, when we're going from the small side to the hypotenuse, we multiply by radical 2. So in this case, we're getting smaller, so we're going to simply divide by radical 2. So let's do the math here. We do 32 divided by radical 2. It's that simple, but we have to rationalize. Now remember, we cannot divide the radical 2 into 32 because they're not both radicals. One's an outside number, one's an inside number. So I need to rationalize. Multiply by radical 2 over radical 2. On the top, it just gives me exactly that, 32 radical 2, just as I see it. On the bottom, remember, when I multiply these two, the radical cancels and I get 2. If I did it the long way, it'd be radical 4, which is simply 2. And then I'm going to simplify. 2 goes into 32, so x equals 16 radical 2. Find the altitude of an equilateral triangle. So I'm going to do my best to make a perfectly equal triangle. Okay, so all these sides match. Remember from the previous chapter, altitude comes from an angle, a vertex, and comes straight down at a right angle. Okay, so remember, before I did this, these were all 60. The altitude is a bisector, so it splits it into 30, 60, 90. It says with a side length of 16. So all of these are 16, but when I split this one, this is going to be 8 and 8. So let's come over here and just draw it separately. Here's my 30, here's my 60, here's my 90. This is 8. The nice thing is it's a small side. All right? Now, I already know this is 16, which, of course, if I multiply by 2, I'd get 16, but I already knew that. I'm trying to find this right here, the altitude. Well, that is the longer side. So when I go from the short side to the longer side, I simply multiply by radical 3. So the altitude is 8 radical 3, and that's it. Simple enough. Find the missing values. Okay, well, this is 45, 45, 90. Y is simply 5 because these legs match. And when we go from the leg to the hypotenuse, we multiply by radical 2. So x equals 5 times radical 2. Y is simply 5. All right, over here I have the 30-degree angle. Remember, if you need to hit pause, if we're going too fast, please do so. Lucky thing here is I have the small side. That's great. When I go to the hypotenuse, opposite the right angle, up here, I just simply multiply by 2. I double it. So x is just going to be 2 times 13, which is 26 radical 3. Now remember, when I go to the longer side, I multiply by radical 3. Well, that means y is going to be 13 radical 3 times another radical 3. Which we've learned, the shortcut is, this is simply 13 times 3 because the radicals disappear. The long way, radical 3 times radical 3 is radical 9. Square root of 9 is 3. And so that means y is simply 39. All right, 45, 45, 90. I have the hypotenuse. These legs are both equal, so A and B are the same thing. When I go from the hypotenuse to the leg, I am getting smaller, so I divide. The magic number on a 45, 45, 90 is radical 2. Therefore, A and B are both equal to 9 radical 2 divided by radical 2. Those cancel, simply 9. And 15, no special right triangle. It's just a, right triangle. So we do a squared plus b squared equals c squared. Remember, always identify your c. Okay, that's what we're trying to find actually in this one. So and it already says c, so that's great. So I have 5 squared plus 10 squared equals c squared. That's 25 plus 100. That's 125. I'm going to square root both sides. I want an exact answer, so I'm going to simplify this one. So I look on my list and find the perfect square number that goes into 125. Well, that's 25. How many quarters make a buck 25? 5 of them. I simplify the magic number, perfect square, and I get 5 radical 5 equals c. That's my hypotenuse. And that's it.